Well, let's look at what's the current state of technology. When I say current state of technology, I focus on the predominant technology, which is lithium-ion batteries. So you might have questions later. I don't know if I will be able to solve questions related to the other energy storage systems, but I think it's quite safe to say that as it's expected that 90 to 95% of future projects will be in lithium-ion technology, that this will cover a lot of the cases. First very, very important thing, safety. There's been a lot of discussion recently, a lot of fear about, well, phones lighting up in fire, exploding. Are lithium-ion batteries safe to have in your house, have in your car? Well, this graph shows clearly different differences between chemistries. We had talked about the basic technology of lithium-ion, but then you have different chemistries that affect what are the additives or the different materials that you use in the electrodes. So if you see the most common type of chemistry nowadays is this one, a blue one called NCM, nickel cobalt manganese. That's a kind of chemistry that's a very high energy density battery, and this one is used mostly for electric vehicles because they can pack quite a lot of energy inside a very small space, but of course with the risk of thermal runaway. As you can see here, the thermal runaway, temperature after which the battery would fail and would release energy, is around 250 degrees. And over here we see these studies from 2005 shows the lithium iron phosphate, the chemistry on the right with the green color, not only fails with a much higher temperature. Nowadays recent studies show over 400 degrees even. That one releases around 4 times less energy in the case of a failure than a nickel cobalt manganese battery. So these batteries tend to be very convenient for domestic applications. Furthermore, nowadays, especially due to the inclusion of automotive techniques in battery manufacturing and the requirements for the safety requirements for public transport, nowadays battery technology is not only very sophisticated in manufacturing, it's very sophisticated in the testing and validation. And in general, every batch of production would go through over discharge, overcharge, put them at high temperatures, low temperatures, crushing, nail penetration, and short circuit. Even the final systems such as full cars or buses will go through this kind of testing. Then performance. There's a lot of questions related to does it make sense to have batteries. It's important to see is, are they being able to provide the kind of performance, and how do I choose a battery? How do I know a battery is fit for what I want to use it for? So this table puts together a number of brands and a number of different technologies. So you see some how do the lead-acid batteries compare with the lithium-ion batteries, some even saltwater batteries, and here you see in the top nickel cobalt manganese batteries comparing the bottom with some lithium iron phosphate. So first factor to take into account is depth of discharge or usable capacity. So when you are quantifying, or when you are trying to make a decision regarding investing in a battery, which they're still not the cheapest kind of investment, you need to make sure that you are comparing apples to apples. So you need to see how much of the size of that battery can I actually use on a daily basis. Second, nominal lifetime cycles. I'll go deeper into this a little bit later, showing some test reports. But it's important to see that the life cycles, nominal life cycles of batteries have been increased significantly recently, from the hundreds to 1,000 cycles that lead-acid used to provide to currently 5,000, 10,000, or even longer lives that lithium-ion can provide. That makes a significant difference when you look at business cases for batteries. Then C rate is something like a discharge rate. So it's how long would it take for a battery to fully charge itself or fully discharge itself. So here you'll see that most batteries in the market, they are between 2 to 3 hours. That's how long it would take to charge and discharge. You do have some batteries in a domestic level, such as the BYD, that is in a 1 hour it will be charged and 1 hour will be discharged. And some batteries from other special manufacturers, they can have discharge rates of half an hour, 15 minutes, so very high power output batteries that are used for special applications. And finally, efficiencies. Lithium-ion has definitely brought efficiency levels much higher than what former batteries used to provide. And then talking about cycles, this is critical to any kind of investor or any kind of person that is going to add a battery to their house, to understand that this is something that can last several decades. And this is a test report provided by BYD that shows a battery cell that reached 22,000 cycles and it still had 50% of their capacity. So you can see that the technology has really reached a point what it will be useful now, and it will be competitive for quite a long time. Then cost. What is the true cost of batteries? This information is provided by Bloomberg New Energy, and it's talking about the price of batteries coming out of factory. And both graphs need to be seen at the same time. So first you're seeing the big drop from 2012, where it was around $700 per kilowatt hour, to what was at the end of last year, 273, and even more. The numbers of less than $100 per kilowatt hour is expected in less than even 10 years. And this is especially thanks to the development of electric vehicles. If you see the graph on the right hand side, the green color is the growth in electric vehicles, and the blue color is the stationary applications. So you can see that most of the growth, most of the economies of scale will be obtained thanks to the great development of electric vehicles. And coming back to what I was saying before about battery cells. So currently in the world, this is important to show because it's important to lose the stigma of Asian manufacturing. Right now, most of the batteries in the world are produced with Asian, both so Korean, Japanese, and Chinese cells. They're at the top in the world, and for the next few years, decade, probably will continue being. And the reason why is because the investment necessary to produce battery cells is enormous. So you do need the volumes, and these are the companies that right now have the volumes, and they will have the sufficient strength to invest in continuing growing these volumes to be able to follow, especially the automotive industry.